All right, welcome back. So here for this question, which isn't too bad, it's saying consider the polynomial p of x, which is this, right? And this is the polynomial, right? It's saying, is 1 a 0 of the polynomial? Well, how can you check to see if 1 is a 0 of the polynomial? There are two ways of checking. You could do this. You could do p of 1. If p of 1 is equal to 0, then 1 is a 0 of p of x. Okay? You could plug in 1 to see if you get 0. That's one way. Or you could take a look over here. Does the graph, let's see, what are the zeros of this graph? Okay? Figure it out for yourself. Where does it intersect the x-axis? Notice that it intersects at -2. I'm sorry, not -2. It intersects at 2, 4, 1 to -3, and -3, -4, -5, -6. So notice that it doesn't intersect that 1 over here. So 1 is not a 0. Okay? Is x plus 3 a factor of this? There are two ways of doing it. The first one way is, what could you plug in here to see if x plus 3 is a factor of this? Pause the video and think, what would the number be? Okay. It would have to be -3. Okay. If you plug in, because it's saying x plus 3, right? You're using the opposite. Why wasn't it the opposite over here? Because when you're talking about the zeros, you're talking about what's on the x-axis. You see, if I say what's the 0 of x plus 3, what's the 0 of x plus 3? Notice that x plus 3 equals 0. The 0 of this is x equals -3. Because when I plug in -3 in here, -3 plus 3 is 0. So is -3, when you plug in -3 in here, does it equal 0? You could check. Or you just look right here. And yes, because -3 it intersects here. So x plus 3 is a factor of p. Okay. The graph of p is shown to the right. What are the zeros of p? Okay, well, we already did it. Well, it's -6, -3, 2, and 4. Okay. But then what is the equation of this? Okay, now take your time. Like if I have -6, what's the binomial that gives me -6? X plus 6. What's the binomial that gives me -3? X plus 3. X minus 2. X minus 4. And you see, if you multiply all of this, it should give you this thing up here. Okay? And that's it for this question. And if you try and do the next part over here, it's really not too bad. It's saying here are the x-intercepts. What is a possible equation for this? Well, notice that if it's -4, we have x plus 4. Try and do it by yourself. Pause the video. Right. If you want to see how it's done, notice that it's x plus 4, x plus 2, x minus 1, x minus 3, x minus 5. Okay? And notice that what's the dance move for this? It's odd positive. So you know that the leading coefficient over here is positive, so then this is okay. But you never know if there's like a value of c over here. So they're just saying put a c over there. And I'll talk about that later in class. Okay. What I want you to do is try and do the rest of the packet. Okay, this is the remainder theorem. Like yesterday, this was your homework. You did A, B, C, D, and that wasn't too bad. Like here, what did you plug in on top? You did f of -2. Here, what did you do? You did f of 3. Here, what did you do? You did f of -1. Now here, what do you do for this one? This one's a little tricky. Pause the video. What do you think you're going to have to plug in here to find the remainder? Notice that when you're saying it's the opposite over here, you're really saying x plus 2 equals 0, so x equals -2. Here you're saying x minus 3 equals 0, so x equals 3. Here you're saying x plus 1 equals 0, so x equals -1. So what are you doing here? You're saying 2x minus 1 equals 0, so then 2x equals 1, x equals 1/2. So you have to put a half in for x to find the remainder. That's a really, I didn't want to give you that question yesterday, but it's a good question. And for the rest, you can do it. Like, try and do this by yourself. It says, consider the polynomial p of x. Find p of 4 in 2 different ways. How can you do this in 2 different ways? Okay. Have fun.